In Activity 11, Opposing Electromagnetic Fields, students will explore how the magnetic fields of two electromagnets can either align to create a strong electromagnet or oppose each other, resulting in no electromagnetic field. You will need the following materials from the kit: Activity Sheet 11, Parts A and B, batteries, battery holders, electrical clips, electromagnet from Activity 8, emery cloth, small paper clips, roll of enamel-coated wire, wire cutters, and masking tape. You will also need to provide metric rulers. To prepare this activity, make a copy of Activity Sheet 11, Parts A and B for each student. Cut a 2.25 meter piece of enamel-coated wire for each team. Sand the enamel coating off 2 centimeters of each end of the wires. Each team will need one battery holder, 2 electrical clips, 2 paper clips, one 2.25 meter length of enamel-coated wire, and an electromagnet. Teams will need access to the masking tape. To begin Session 1, inform students that they will be investigating electromagnets and what makes them work and not work. Distribute an electromagnet and a 2.25 meter piece of enamel-coated wire with ends sanded to each team. Have the students count the number of wraps of coil on their existing electromagnet and add or subtract wraps so that they have a total of 100. They should then cover the coil with masking tape. Each nail and coil should still have the 2 rubber rings attached. Then, with the 2.25 meter piece of enamel-coated wire, have the students wrap a second coil on top of, and in the same direction as, the original coil. These coils in the same direction are referred to as aligning. The second coil should also contain 100 wraps in the same direction as those in the original coil. Next, stimulate discussion by asking students, what would happen if 2 coils of wire were wrapped around the nail? Students may understand that the nail would become a very strong electromagnet, almost twice as strong as it was with just 1 coil. Distribute the copies of Activity Sheet 11, Part A, and the remaining materials, and have the students complete steps 1 through 5. Next, ask students, what did you observe when you reversed the battery connections of just 1 coil? They should have seen that when the ends of 1 coil were connected to the battery in reverse, the current flow in that coil was reversed, causing the electromagnetic fields of the 2 coils to oppose each other, canceling any effect on the nail. To conclude Session 1, ask students, what is the evidence that the 2 electromagnetic fields cancel each other? Students should understand that if the fields are canceled, then no electromagnetic field will be created. Therefore, the paper clips could not be picked up by the tip of the nail. To begin Session 2, let students know that in this session, they will change the direction in which one of the coils is wrapped. Inform students that opposing means going in opposite directions. The coils going in opposite directions are referred to as opposing. Next, tell students to unwrap the top coil of wire from their electromagnets and leave the original coil taped to the nail. Have them rewrap the wire in the opposite direction of the first. Assist any teams that need help. Then, distribute the copies of Activity Sheet 11, Part B, and the remaining materials, and have the students complete steps 6 through 10. After most or all of the teams have finished Part B, ask, what did you observe when you reversed the battery connections of just 1 set of coils? Students should have seen that when the ends of 1 set of coils were reversed, the current flow in that set of coils was reversed. The electromagnetic fields of the 2 coils became aligned with each other, causing the nail to become an electromagnet. In this setup, when the current flowed in the same direction, the fields opposed each other, canceling any electromagnetic effect. Next, ask students, how does this compare with what you observed in Session 1? They should respond that the results indicate that the creation of an electromagnet does not depend on the direction of current flow relative to the nail. Then ask students, on what does the effectiveness of the electromagnet depend? Help them conclude that the effectiveness of an electromagnet depends on the number of coils of wire wrapped around the nail and, if more than 1 wire is used, the direction of the current flowing through those wires. In an electromagnet with 2 wires, if both current flows are in a clockwise or counterclockwise direction, the 2 electromagnetic fields will align. If one is clockwise and the other is counterclockwise, the fields will oppose and cancel each other. Finally, Discuss the factors that result in the creation of an electromagnetic field. Summarize what the students have observed by drawing a chart similar to the one in Figure 11.3. To conclude Session 2, remove the second coil of enamel-coated wire and the layer of tape from each of the electromagnets. Return the wire, electromagnets, batteries, battery holders, electrical clips, and paper clips to the kit. For science background, reinforcement activities, curriculum connections, and information about the Delta Science Reader, please consult your DSM Teacher's Guide.